So let's look more at radian measure. So first off, we're going to go over the special triangles using radians instead of degrees. So our first special triangle is an isosceles right triangle, which means we have two equal side lengths, which we can take as 1 and 1. And again, using Pythagorean's theorem, we can get the hypotenuse is equal to the root of 2. Recall that 180 degrees is equal to pi radians. So therefore, 45 degrees would be equivalent to pi over 4 radians. So 1/4 of 180 is 45 degrees. So if we were to see a triangle that contained pi over 4 radians, this is our opposite, this is our adjacent, and this is our hypotenuse, then the sine of pi over 4 would be equal to 1 over root 2, or root 2 over 2. The cosine of pi over 4 would be 1 over root 2, or root 2 over 2, and the tan of pi over 4 would be equivalent to 1. For our second special triangle, the equilateral triangle, we took all the side lengths to be equal to 2. And we note that for an equilateral triangle, each angle is 60 degrees. If 180 degrees equals pi radians, then 60 degrees is equal to pi over 3 radians. If we split this triangle down the middle, then we get our second special triangle, which has side lengths 2, 1, and then with Pythagorean's theorem we can show that the height is root 3. We know that this angle is pi over 3, and that the top angle is pi over 3 divided by 2, which is equal to pi over 6. So then again, we can determine the sine of pi over 3, the cosine of pi over 3, and the tan of pi over 3. So if this is our angle of focus, then this would be our opposite side, here would be our adjacent, and here would be our hypotenuse. So sine of pi over 3 would be root 3 over 2. The cosine of pi over 3 would be 1/2, and the tan of pi over 3 would be root 3 over 1. And then we can do the same thing with pi over 6. If that's our angle of focus, then the sine of pi over 6 is 1/2, the cosine of pi over 6 is root 3 over 2, and the tan of pi over 6 is going to be 1 over root 3, which is equivalent to root 3 over 3. So next, determine the exact values of each trigonomic ratio and verify using your calculator. So the first one is the sine of pi over 3. We've already shown that one above, and that is root 3 over 2. But if you wanted to draw sine of pi over 3, what I recommend you do is to split your triangle in half, and since it's pi over 3, we're going to split it into 3 equal segments on both sides of that horizontal line. So this rotation here would be 1 pi over 3. So that would be what the angle looks like. So pi over 3 plus another pi over 3 plus another pi over 3 gets us all the way here to pi, which is 180 degrees, or half the rotation of a circle. So what is the sine of pi over 3? Well, then we use our special triangles. So we have the sine of pi over 3. We go back to our special triangle, look at pi over 3, take the opposite over the hypotenuse, which is root 3 over 2. Let's do a more complex one. What about 3 pi over 4? And we want the secant of that one. So this time we're going to split each half into 4 equal parts. So there would be 1 pi over 4, 2 pi over 4, there would be 3 pi over 4. So notice we are in quadrant number 2 if we're looking at 3 pi over 4. So let's write an equivalent expression. So we have secant of 3 pi over 4 That's the same thing as 1 over the cosine of 3 pi over 4. So cosine of 3 pi over 4. Well, what's our related acute angle? Since we've drawn it this way, we see we have a related acute angle of pi over 4. Since we split this up into equal segments of pi over 4. So what we have is 1 over the cosine of pi over 4, which we can evaluate using a special triangle. But we must include the fact that since we're in quadrant 2, we need a negative here. And now we can evaluate this ratio. So we 1 over negative, and the cosine of pi over 4 is 1 over root 2. If we divide by a fraction, we multiply by its reciprocal. So we get 1 times root 2 over 1, but still negative, which is equivalent to negative root of 2. So that is what secant of 3 pi over 4 is equal to, negative root 2. So let's try a couple more. So let's do another one split into pi over 4s. So remember, we split this in half. And since it's pi over 4s we want, we're going to split this into quarters in the top and bottom. So we want 5 of these. So there's 1 pi over 4, 2, 3, 4, and 5. So this whole rotation here is 5 pi over 4. Again, we're going to need the related acute angle. So one of these here is pi over 4. So let's write an equivalent expression. So the cosine of 5 pi over 4 is equal to, since we're in quadrant number 3, the negative of the cosine of pi over 4. So again, we get this negative because we're in quadrant number 3 and cosine is negative. And then the last part is just to evaluate. So once again, we have the cosine of pi over 4, so this is negative 1 over root 2 or negative root 2 over 2. Last one, the cosecant of 11 pi over 6. So this one we're going to have to split into 6 sections in the top and bottom. So we want to go 11 pi over 6. So I'm just going to go right to it. There's 12 of these pi over 6s. So we're going to go all the way over to 11 of them. So there's 11 pi over 6, which leaves us with a related acute angle of pi over 6. So let's write our equivalent expression. So we have the cosecant of 11 pi over 6, which is equal to 1 over the sine of 11 pi over 6. Once again, we have 1 over the negative because we're in quadrant number 4 and sine is negative. Negative sine of related acute angle pi over 6. So now we have 1 over the negative of sine of pi over 6. And if we go back to our special triangle, there's pi over 6. The sine of that is 1 over 2. And 1 divided by 1 over 2 is equal to just negative 2. So again, these are your grade 11 questions now using radians. So let's look at the last one. Determine the values of theta between 0 and 2 pi, so it's between 0 and 360, given that sine of theta equals negative 1/2. So there are 3 steps to this. So first step, let's figure out what quadrants we are in. Since sine is negative, we must be in quadrants 3 and 4. So let's draw those 2 terminal arms. So we're in this quadrant and in this quadrant. So we want to figure out this angle here, we'll call it theta 1. And we want to figure out this angle here, we'll call it theta 2. Next, we need the related acute angle. So the related acute angle is equal to the sine inverse of the positive ratio 1/2. So as long as your calculator is in radian mode, you can figure this out, but that'll give you an approximate answer. We want the exact answer, so we're going to use our special triangle. So since we want sine is equal to 1/2, we want the 1 to be our opposite side, and our 2 to be our hypotenuse. And for that to work, that means that pi over 6 must be our angle. So now we have our related acute angle is pi over 6. So that's this angle here, and that's this angle here, the angle it makes with the x-axis. So now we see that theta 1 is equal to pi plus pi over 6, because remember pi is equivalent to 180, and theta 2 is equal to 2 pi minus pi over 6. Again, 2 pi is our 360-degree rotation. So next step is to find a common denominator. So I see I have 6 pi over 6 plus pi over 6, which means our first angle is 7 pi over 6. And for our next angle, we have 12 pi over 6 minus pi over 6, which gives us 11 pi over 6. Let's go to the next one. Cosine theta equals -1. Now there's going to be a special rule when you see plus or minus 1 for cosine and sine. If you're to see plus or minus 1, what I would do is draw the base graph of cosine. So here's our base graph of cosine. It starts at the max and ends at the max. And cosine theta equals -1 at one value, right here. So recall that we would say that is 180 degrees, but since we're talking radians, that is going to equal pi radians. And that's it. Just examine it from the base graph. If we said cosine theta equals 1, well, that would be at 0 and 2 pi radians. And if we were dealing with sine, as long as you draw the right base curve, so this would be the sine curve, you can also figure out where sine is equal to +1 and where is sine equal to -1. And our last example, what angle gives us a tan ratio of 7/24? First of all, we know that we're in quadrants 1 and 3, since tan is positive. So let's draw those two terminal arms. So there's one in quadrant 1, there's one in quadrant 3. So there's theta 1, and here is theta 2. Next is to find our related acute angle. So our related acute angle is the tan inverse of the positive ratio 7/24. So if I want to determine the value of theta 1, I already see that that is just the tan inverse of 7/24. This is not a special triangle, so we'll have to use a calculator to determine this value. And theta 2 is going to be pi plus the tan inverse of 7/24. Next is to use our calculator to determine this angle. So if you use your calculator and make sure it's in radian mode instead of degree mode, we're going to get that theta 1 is approximately 0.284 radians. And therefore, theta 2 is pi plus 0.284 radians, which is approximately equal to 3.425 radians. So this would be a calculator question since 7/24 does not fit any of our special triangles. Please try the following questions.